So complex fractions and complex numbers today. Who can tell me what do we mean when we talk about a complex number? Come on, you guys know what complex numbers are. What are we talking about with complex numbers? Evelyn? No, not when it just has a variable in it. Ted? That's when we have I, the imaginary things in there. What about a complex fraction? And we actually had one of those. It was number 19 on that review paper that I already gave back to you guys. What's complex? There's more than one fraction bar in it. So those are the two things we're going to talk about today. So complex fraction has more than one fraction bar. A complex number has an I in it. So a plus bi, or maybe it starts off looking like the square root of -7. They come from square roots of negative numbers. So then that one becomes the square root of 7 times I, or 0 plus the square root of 7 times I. So those are our two things for today. So this is kind of like that number 19 that was a little bit of a challenge since we didn't actually get to lesson 64 last semester. This b is all by itself. It's not part of anything with a fraction. It is not at all complex. So I'm not going to worry about it for right now. It's going to stay b plus something. But that other part is a mess because I do have this little fraction inside of the big fraction. So it is a complex fraction. So that's the part that I want to try to clean up a little bit here. To do that, I am going to say, oh, I'm going to look at the little fraction inside of it, and I'm going to find the little teeny tiny denominator in there, which is just a z. What's my small denominator in there? So then I'm going to find my main fraction bar. And even with that, I'm going to multiply the main numerator by z and the main denominator by z. And the reason it's z is because that is my little teeny tiny denominator inside of there. So the b stays the same. Now when I multiply a fraction, I multiply the numerators. 1 times z is easy. That's just z. Now I need to multiply my whole main messy denominator by z. Because I have a plus sign in that original main messy denominator, I have to distribute. So here I get 1 over z times z. That's z over z, or just 1. Then I finish my distributing, and this part is plus 2 mz. So we're not finished, but give me a thumbs up, thumbs down. Are you with me so far on this? Now it is no longer complex, but it's not simplified. Now I simply have two fractions that I need to add. When you add fractions, what do you have to do? What have you had to do with fractions since elementary school? If you want to add fractions, what do you need, Brian? We got to get a common denominator. Only one has a denominator, so I'm going to let that be the common denominator. And if I want this to have the denominator of 1 plus 2mz, I have to multiply the numerator and the denominator by 1 plus 2mz. So when I do that, if I'm multiplying something with a plus times b, I have to distribute. So I have b plus 2bmz from that first part. Then from this one, I add the z, and I put it all over the common denominator, which was 1 plus 2mz. And I don't see any other terms I can combine. I don't see any GCF I can factor out. So I am finished, and that is my final answer, where I have just one fraction for the whole thing with one fraction bar. Questions? Let's do another one before we move on to our complex numbers. Okay, S over Z, is that complex? So we're going to keep that S over Z plus. Then this part, though, Is that complex? Yes, I've got a little fraction inside of that big fraction. So I look at my little fraction, I look at my little denominator, I only have one, it's a z again. We're going to get to ones in a future lesson where they're messier, but for right now we just have the one and it's just the single little letter z. So I am going to line up even with my main fraction bar, multiply my main numerator by z and my main denominator by z. Numerator, I just multiply the numerators together, and I have 3z. Denominator, I have a plus sign, so I have to distribute that z, so I multiply that whole denominator by z. So I have the 5 times the z plus 2sz over z, the z's cancel, and I just have 2s. Now I need a common denominator, and it's a little bit messier than the last one. But before I do that, thumbs up, thumbs down. Are we okay so far? Okay, now I need a common denominator, which is going to have to be z times 5z plus the 2s. Everybody okay with that's what our common denominator has to be? They don't share any factors. So this one I have to multiply by 5z plus 2s, and it's not okay to say I do that. I can't multiply just the numerator by that. Even if I actually do it, I have to write it down or the work is wrong that I'm also multiplying the denominator by that. So that one I distribute, and I have 5sz plus 2s squared, I think. If I'm not confusing myself with my s's and my 5's, be very careful with s's and 5's. A lot of times I'll do a cursive s so I don't get mixed up. So far, so good for that first piece. Okay, this one I have the 5z plus 2s, but I need to multiply numerator and denominator by z. That one's a little bit easier. I just have 3z squared. Do I have any terms I can put together in the numerator? Do I have anything I can factor out? So I am finished, and this is my final answer. So questions with complex fractions, just think it through one piece at a time. Okay, moving on to complex numbers. If we have ones that have negative square roots in there, it is not mental math. You're going to make mistakes if you try to do it in mental math. It is not square root of 6. You can't just multiply the -2 and the -3. That does not work. First step, anytime you have a minus inside a square root, before you do anything else, write down that that is a square root of the same positive thing times an I. Write down that the square root of -3 is the square root of the positive 3 times an I. Then you can put the root 2, root 3 together as root 6. Put the i's together as an I squared. But who remembers what I squared equals? Everybody shout it out. Since I squared is -1, that gives us minus root 6. But I want to see this work done. Every time there's a square root of a negative, I want it written down as a square root of a positive times I. Okay, this one has square roots of negatives. We're going to do that same thing to them. And it's already got other powers of I. So for this one, we are going to remember that I squared is, what did you just tell me? -1. I cubed is that same thing times one more I, right? So it's minus I. And I to the 4th is that minus I times one more I. So that's minus I squared, but I squared was a -1, and minus 1 is a +1. And then they just repeat I -1 minus I1 if we get to bigger powers. So that means we can change our I to the 4th to a 1. The I cubed we can change to a minus I. We are going to keep this first minus 3. We are going to change the square root of negative 3 to the square root of 3 times I. We are going to write down that we are changing the square root of negative 5 to the square root of a positive 5 times I. So far, so good. Then that means that we have 1 minus minus is a plus, so plus 5I minus 3 times the square root of 3 times the square root of 5, so that's a square root of 15, times an I squared, but what's I squared again? Negative 1. So if that's a negative 1, that means that this becomes a plus 3 root 15, and we still have the 1, and we still have the plus 5I. Now I changed the order around just a little bit. Can anybody tell me why I changed the order? Ted? The I has to be very last. I have to have one real number plus or minus one real number times I. I can only have one I in there, and it has to be very last, so the I part's okay. But the way I wrote it just now, I have two real numbers plus something times I. So to make it be just one real number, all I have to do is add a parentheses to say that's the real part. I can't simplify it, but I just put parentheses around it to say that's what I'm talking about. Anybody else with a question though? Okay, then last one for today. If we have two complex numbers and we want to multiply them. So 3 plus 5I times 4 minus 5I. First step is we're going to FOIL it just like we would if the I was an X. So we're going to write down that we have the F's, 3 times 4 is 12. 3 times the minus 5I, positive times negative is negative 15I. And that was O's. Insides, 5I times 4, plus times plus is plus 20 times I. And then positive times negative is negative. 5 times 5 is 25. I times I is I squared. Are we good with that's what we'd be doing if it was an X? The extra step we now have is we have to, well, we still would have to combine like terms, but we have to deal with the powers of I and writing it in the right form for a complex number. So once again, what is I squared, everybody? Negative 1. So the negative 25 times negative 1 becomes a plus 25. So I've really got the 12 plus 25 to put together, or 37 if I manage to add that correctly. And then if I put together minus 15x plus 20x, or really minus 15I plus 20I, what do I have, everybody? I don't have plus 5. I'm not going to say 37 plus 5 is 42. Plus 5I. We'd have to write an X if that were an X. Since it's an I, we write it as a plus 5I, and there is my I at the end. So questions from anybody else? All right, we still have a little over 15 minutes, so I'm going to have you guys start with 16, 14, and 8.